Okay, welcome America, welcome Justin Bieber. I would like to apologize for my appearance today because after the gym, when I got to school today, Vandy and Hastings said, hey, why don't you come run some drills with us at the on the field? And I was like, sure. And now I'm dead. They really hurt me, which is a good thing, I guess. All right, so today we are going to review for our test on circles, our first test on circles. And I've picked some problems that are very similar to some of the questions that are on your test. So we're going to start with I can attach this worksheet as well. We're going to start with number 5. So we're asked multiple questions about this one diagram. Whenever you get a question like this, where you have one diagram and multiple questions, you want to make sure that you answer the questions in order, because sometimes you might need the first one for the second one and to answer the third one and so on. I know I've told you that before, but it's nice to have it in a video so you can remember later. All right, the measure of arc, WE. Where is WE? WE. Notice these two endpoints are across from this angle 47 degrees. I'm going to draw that in there for you. So you can kind of see it. So this arc in green is the one they're asking for here. Why is my board so slow? It's drawing after I draw. Did you notice that?
Yeah.
So weird. Okay. So what's the measure of this arc right here? The measure of this arc, this is an inscribed angle. So this angle is half of this arc. So what's the measure of this arc going to be? Someone better have a calculator out. 47 times 2. I'm going to write 47 times 2. Just so you remember where that came from. 94 degrees. Okay, moving on. Stop me if you've got a question. Is there a hand up? No. Okay. The measure of angle WXE. WXE. Notice the endpoints are still in the same place. And X is the vertex. It's just still on the other side of the circle. So this angle is also 47 degrees. Let me draw that in. It's across from the same arc. This arc is across from this inscribed angle. This arc is across from this inscribed angle. They're the same. So the measure of angle WXE is 47 degrees. And the measure of angle WXY. WXY. Notice the endpoints of this inscribed angle are on either end of a diameter, which means this arc, half the circle, is across from this angle here. WXY. This arc, half the circle, is 180. It's twice as big as the angle we're looking for. So that angle is going to be 90 degrees. Questions? We are going to move on to number 7. Number 7 asks you to determine if line AB is tangent to the circle. In order for this line to be tangent to the circle, it needs to be perpendicular to this radius. And the only way we're going to know if that's a right angle is if we use the Pythagorean Theorem. We have the 3 lengths of the sides of the triangle. So we're going to throw those lengths into the Pythagorean Theorem. Make sure we put in the longest side as C across from the right angle. And see if it works. If it doesn't work, that means it's not a right angle and therefore not a right triangle, and therefore the line is not tangent. So C squared equals A squared plus B squared. So let's check it on the calculator. What were the numbers again?
8.9 squared.
Can you guys read them off to me? Okay, so 8.9 squared
3.9 squared
plus 8 squared.
Yeah.
Okay, those are equal. So we've got ourselves a right triangle because a squared plus b squared does equal c squared. So I'm going to put a little check here. They're equal. So to determine if line AB is tangent to the circle, we can say line AB is tangent. Moving on to number 9. This is one of those ice cream cone problems. So we've got two tangent lines, and when they intersect at a point outside of the circle, these lengths are equal. So in order to solve for x, all we're going to do, like we've done a billion times this year so far, is we are going to set them equal to each other. So we're just going to set them equal to each other and then solve for x. So we've got 15x minus 2 equals 13x plus 2. Solve for x. I'm not going to solve for that because I think you guys can do that. The question says solve for x. All you have to remember to do for the ice cream cone problems are just set them equal and solve for x. And once you have x, you're done because it's just asking for x. I love it. Love it. You don't have to do anything with the x. I'm trying to get to number 11 here. These are the trickier types of problems. So I'm going to show you how to find a couple different lengths in this problem because these questions, it's similar to what you're going to be asked on your test. So let me draw some things in here. So here is the radius, 9.4, right? This is also a radius, 9.4. I'm not gonna write that on there, I'm gonna get you confused, okay? So what else do we know? This chord has been intersected by a perpendicular line, which means that these segments are equal. So if this length is 8.9, this length is also 8.9. I'm gonna draw that on there because in a different color, that's a right triangle there. And if I can use the Pythagorean Theorem to solve for this missing length, which I'm going to call y. I'm just going to go crazy, call it y. If I can solve, it's weird. If I can solve for y, and I know that the radius is 9.4, then I can just subtract that length from 9.4 to get my x unknown. I think that's really all I wanted to show you that problem. Okay, so Pythagorean Theorem it. So we've got C is across from the right angle. 9.4 squared should equal 8.9 squared plus y squared. So read those numbers off to me again. So 9.4 squared minus 8.9 squared, right? Okay, that is b squared or a squared, whatever I had unknown there. This is squared, so I have to take the square root of that number. So the square root of 9.15 is the length we need. 3.024. I'm going to round to the hundredths, so that means I'm going to take this 4, and I'm going to cut it off after the 2. Right? And then look at the number after it. 4 below, let it go. 5 above, give it a shove. That's a 4 below. So I'm going to cut it off and let it go. So that's 3.02 for that length. 3.02, where I'm at. Now, the radius minus 3.02 equals x, whatever that is. Are we good? Any questions? Is anyone wearing mom jeans right now? Nobody? I know you guys have them. I tried them on yesterday at Kohl's. It was super exciting. They were actually legit. They were called mom jeans.
Yeah.
What?
But
It's a cut. It was, I was like, who buys these? Nobody. Nobody. Except for my daughter. And y'all, I've seen you guys wear them. Couldn't get I'm not wearing those. Okay, wear them tomorrow. Will you wear them next class? You have a cameo in my video. If you wear mom jeans, you get a cameo in my video. Okay, that goes for everybody at Heritage High School. You want to stop by while I'm recording and show us your mom jeans. We're all about it. And here's an update on my bus pass collection. So many. I got like 5 today. And Faith almost lost her bus pass. I was like, what? How could you lose a bus pass? Unacceptable. All right.